Say that we have some electric field, and inside that electric field we have some, let's say, surface, and on that surface, let's say, we have some small area delta A. Through that small area passes electric field, and we have a normal vector on it, which is perpendicular, of course, to that small area. For direction, we can choose either this direction or completely rotated by 100 degree, but it's completely arbitrary. You can choose whatever you want. We can choose here, we choose this direction. And between the normal vector and the electric field, we have some angle theta. And electric flux is defined as the dot product between electric field normal vector times small area of the delta A of that small area. And we can write this as a magnitude of electric field times this small area times cosine theta, which is the angle between normal vector and electric field. Now let's say that we have some closed surface. The shape of that closed surface can be anything you want. It can be completely arbitrary. Let's say that we have some closed surface which is like a potato, and on that surface we have we can define like small areas delta A. We can divide into a lot of small areas delta A, and normal vector, which in this situation, for this kind of closed surface, or any kind of actually closed surface, normal vector points from inside that closed surface to the outside. And the flux through this closed surface, it will be the sum of all those small teeny areas times the vector electric times the normal vector times electric field. And we need to mark that this is actually a closed surface, the integral of the closed surface. Now let's try to calculate surface flux, let's say through the sphere. And let's say that we have some electric charge here, Q, and we have the sphere, and on distance r, let's say this is this charge, let's say in the center of the sphere, and let's say so we have the electric field which points radially from this charge to out, all around the sphere and through the sphere. And we have a normal vector as well here, which is perpendicular to the sphere but is parallel to electric field. And we can write this as, if we use this formula, that the flux through this sphere is equal to electric field times dA, but since the cross dot product here actually it's 1, we can write that electric field times dA But actually, since the charge is in the center of the sphere, and on the radius r, and the electric field on the sphere is at each point is equal, so we can take out this electric field in the front of integral, and we have actually here this integral actually is the surface area of the sphere, and it is equal to 4 pi r squared, and this is a flux through this sphere. But electric field, from Coulomb's law we know that electric field is equal to electric charge divided by 4 pi epsilon r square. And if we substitute with this, we have that flux is equal to charge divided by epsilon naught. And the thing is that we can actually have any kind of surface. It can be completely irregular like this one, and we will also have that the flux through that surface is equal to this. And we can see that this flux is not dependent from the distance r here, it's completely independent. And also we can have more than one charge here, and it will be equal to the sum of all those charges inside that closed surface. So the Gauss law actually is this one here, that is equal to the sum of all charges inside that sphere. So this completely not sphere, I mean inside the closed surface, and the closed surface can be completely with some random shape like potato or whatever you can imagine, and the flux through that closed surface, it will be equal to the sum of all charges divided by epsilon 0. So, and this is also the first Maxwell equation, and you're probably asking yourself, so what's the importance of Gauss law? So Gauss law is a tool to calculate the flux through some area. For example, flux through this sphere, it was pretty much easy to calculate. But let's say that you want to calculate the flux through this kind of closed surface, like this one, like a potato. It will be very, very hard. But with Gauss law, actually it's quite trivial. You just need to sum all charges. You just need to sum all the charges that you have here inside the, let's say, that closed surface area. Let's say Q1, Q2, Q3, and you sum them all, and that's the flux through that surface area. So that's the importance of Gauss law. Gauss law is a tool which can simplify it and make your life, which can simplify the calculation and makes your life much easier.